Let's take a look at a third order determinant example. So in this example, you can see we have three expressions. Each expression has three terms as well as the constant. So just like we did with the second order determinant, we have to expand or decompose each of the expressions into its elements, A1, B1, C1, K1, etc., for each of the expressions. Again, at the bottom here, you can see the little map that you will use to produce the determinants in their mathematical form when you do your solutions. So as we line these up, you can see here, we find the denominator. Since it's common to all of the solutions, we can set it up this way. So you see we have 1, 2, 3, 1, 2, 3, 2, 1, 4, 2, 1, 4, 3, 2, negative 3, and then we take the first two rows and expand them off to the right, and then we create our diagonals, keeping track of which ones that we add the products and which one that we subtract the products. And so here on the bottom you can see that we have 1 times 1 times minus 3 plus 2 times 2 times 3 plus 3 times 2 times 4 minus 3 times 1 times 3 minus 1 times 2 times 4 minus 2 times 2 times minus 3, which gives us then, when we sum these up, a denominator of 28. Okay, so now what we do is we solve for x, we solve for y, and we solve for z the same way. So as we said before, each of the numerators are going to be a little different because the row expansions are different. Okay, so now we have 14, 10, and 2, 2, 1, and 4, 3, 2, and minus 3, and then we carry those other two rows over. Take the products, take the sums and differences, and we end up with our first value for x as 28 over 28 when we sum everything, which gives us 1. Do the same thing for your y terms. Take the sum and differences of each of those products. We end up with 56 over 28, which gives us 2. So y equals 2, x equals 1, and we do the same thing for z, the products, each of them sum and difference. We end up with 84 by 28, which gives us a value of 3. So 1, 2, and 3 are our solutions using the third order determinant method to solve for these three linear simultaneous equations. So you can see that doing the third order was just added one more level of methodology, nothing really too difficult to do. Again, I encourage you to pull out Excel and try writing a quick little spreadsheet that will solve for second order and third order determinants, so that in essence you wouldn't have to type these out every time or put them on your computer. Again, check out your computer, your calculator. I know that there are determinant functions in the calculators. Pull out your book and go through and determine how to create them. If you've got a programmable calculator, my old one here, this one here is like 35 plus years old, but it still works. It is a completely programmable old Hewlett-Packard that actually has a library in it, a math library that will do this for any order of determinants. So when we come back, we'll take a look at the last sections here. We've got applications with one source and applications with more than one source that we need to take a look at for an example in electronics.